Okay, good morning, Jane and Susan. I'm going to give this a go. So what you see here are four fixed Mendeleev dividers. A Babylonian clay tablet, pair of scissors, paper. This is a caliper to capture dimensions. These are dividers that also can capture dimensions, but are basically to transfer and scribe measurements. Here's some clay. And oh yeah, and I forgot. So these dividers, Mendeleev dividers, we have two for water, and we have one for carbon and cellulose, and then we have one for carbon to carbon dioxide. And as you can see, they jump in scale. And this one here, which is the largest one, the carbon to carbon dioxide, I put some points on there. This is probably not safe for children, but these are sort of prototypes. I had maple, these strips of maple, so I just put this together so I could do this demonstration. Oh yeah, and the points here are actually glued in with pine resin, which I'll tell you something else here. So over here, I don't know if you can see it, but those are pine resin earrings that I made for Christmas. I gave to my mom and my daughter, my wife, and my cousin. So, sorry, I'm on a tripod, so I have to sort of set this back up again. Anyway, I've been doing a lot of work with pine resin. Exploring recycled materials, reuse of old materials. And what's interesting, can't see. So what's interesting about this clay tablet is it could be made out of pine resin and beeswax. One of the advantages of that would be that it could be a sort of a hard surface, but in the sun you could warm it and easily, sort of erase everything that you scribed onto it. And as long as it wasn't in the sun, it would stay a very long time. And if it was important information, just like the Babylonian, it could be kept like the original Sumerian Babylonian. And I actually got to sort of handle one of these tablets at the ROM, and some of them were preserved because of destruction, because they didn't always fire these things, so some of them, because of war or damage, were baked in firing. And so that's why some of them were, some things weren't actually intended to be saved for thousands of years, but ended up being so. There's some interesting features about this. Yes, it looks like a piece of framed clay, but what's nice about it incorporates 4 straight edges. And so this clay tablet actually has a ton of potential, and hopefully you'll see some of that. Okay, now, I mean, I could go into more detail about this stuff. I don't think you're that interested. But so I know you want me to hone this thing into the landscape observational room or site, and so so that's what I'm going to try to do. So how using powers of observation, and if I were to be more aware of the environment and your surroundings. So how would I, if I were to do this as a form of instruction, and before I would start, I'd like to talk about observation, and it's sort of an essential toolbox, and expressing it in terms of our five senses for children, and get them to talk about the five senses, and perhaps even suggest others outside of the five. So I've put a small outline together about if I were to do something like that in front of kids. I would really like it. I mean, for me, it would be a wonderful challenge, and something I've enjoyed in the past, but had rare opportunities to do so. And so anyway, so I'll send you this this kind of outline of how I would engage with the kids, or attempt to engage with the kids. One thing I'd like to say too about observation and measuring is that, and I think I could bring the kids along in this, is that, when you talk about the five senses, one thing that's interesting about, let's say, using your senses to cross the street safely is how do we make those senses, crossing the street, listening to the traffic, feeling our feet walk across the pavement, judging depth, all these sort of perceptual things. How do we commit those to memory? And so the next time we encounter the street, we actually know what to do. And fortunately for us, our senses are designed actually to measure. So not with rulers and tape measures, but they're sent to measure through comparison, and so that we can taste if something's too sour or sweet, or we hear something that's perhaps too quiet or too loud, or we're trying to see something that's either too far away or perhaps even too close to focus on, or too dark or too light. Anyway, so our system, our perceptual system, is actually wired to actually measure, and it's those things that actually are essential for us to be able to motor around, that we've actually made record of those in our mind body workings. And that, I think that would be a nice tie to your perhaps some of these measuring tools, or going out and measuring. So what I'm hoping to trigger the kids about this whole project would be to say that, you know, with a few old or ancient tools, with the help of the Babylonian clay tablet and Mendeleev's dividers, we're going to attempt to measure the amount of stuff in a leaf, and we're going to try to measure the amount of carbon a leaf captures or utilizes in its growth. So one of the so anyway, I think, you know, I need just to talk a little bit about Mendeleev. So he lived around, well, nearly 200 years ago, and he was one of these guys that asked this basic question: what is the universe made of? And astonishingly, he actually answered those questions. And he attempted to organize his findings in a chart, in a list called the periodic table, which puts in order the elements of the universe. And what is an element? Well, an element is something, is a material that cannot be made into any, can't be divided into anything else besides this basic material. So let's say gold. Gold can't be broken up into any other material besides its atoms and electrons. Where, let's say, salt, it can be broken up into sodium and chlorine. So salt is not an element, it's a compound. So Mendeleev was one of these guys who was exploring what his surroundings are made of, and then he listed them in a chart by weight and other things, but we're going to focus on weight at this moment. So the Mendeleev dividers actually do two things. They incorporate the weight, so the weight of something, and establishing a unit length for it, or a unit measurement. And that was very important. So hydrogen is one of the lightest the lightest element, which the sun is made of, basically mostly hydrogen. And all the way to very heavy elements. Let's say lead is much heavier, and it's a metal. So he organized the periodic table, and what I've done is I've just stretched it on a line. So I took all the weights and marked them out. And in the graphic I showed you, it actually shows the periodic table of the elements stretched out as a linear line by millimeter. And so hydrogen, well, this is 0, let's say. Electrons are actually somewhere around 0. This is, actually we'll draw a line here. So